In this class, we're going to consider how you solve quadratic equations where you're factorising the quadratic expression as a trinomial. So these are probably the most popular and the most difficult, unfortunately, form of a quadratic equation. So remember, a quadratic equation is just a quadratic expression set equal to 0, but the quadratic expression can be in different forms. It can be in a form where you factorise as a trinomial, like this guy here, in fact all of these. It can be in the form of a difference of two squares, or it can be in the form of a binomial. So those are your three options. They all require a different type of factorization, but the overall method for solving the equations are the same in each of the cases. We factorize using whatever factorization method we have to use, and then we split it off into two equations and solve them. The end part is quite trivial. It's a factorization part, and remembering the rules for each of the types that tends to be the most troublesome part of the process. So we're going to work these examples in a moment, but just a reminder that in general a quadratic expression is ax squared plus bx plus c, and a quadratic equation is just that guy set equal to 0. So that's what we're dealing with here. Everything apart from the a can disappear. The a and the x squared, so I mean the b and the c can be 0, and you've still got a quadratic equation. But for a quadratic equation, you need to have at least the x squared term. For this type here, a, b, and c are all present. So we've got an a, b, and c value giving us a trinomial. So I'm not going to explain in this class how you factorize trinomials. Check out a class on that if you're not sure. I'm going to assume that you're already familiar with that technique, but I will kind of talk about them as I go through. That is really the question here. Can I factorize those trinomials? It's not so much the overall approach to solving the equation as it is just getting them factorized. One big mistake I see with these, and indeed all the forms of quadratic equation, is trying to solve them like a linear equation. So remember, a linear equation is something like this guy here, where you don't have a square term, and we would solve this by taking the x term to one side, taking the number term to the other side, and then dividing at the end. Quadratic equations are not like that at all. We solve quadratic equations by factorizing or using the quadratic formula, like a numerical method, but we're focusing on the factorizing here. But a lot of students will move, for example, the -9 to that side, keep the binomial term here, and then basically get muddled at that point because it doesn't seem to be working out. So just remember that these are very different in the approach to solving them than linear equations. So linear equations are just normal equations, like the first equations that you learned to solve. Okay, right, so let's get stuck into these examples. So we'll start with this one here. It's a trinomial. We're going to factorize it into two brackets. So this one would need an x and an x to make, we need two numbers to make a 12 and to combine to make a 7. So the two numbers, remember, are multiplying to make 12, so 4 and 3. I've chosen 4 and 3 because they multiply to make 12 and they combine to make 7. If we use a plus and a plus, then we'll get a plus 12, which is what we need, and we'll get a plus 4x plus another 3x to give us the positive 7x. So we're done with the factorizing at that point. To take this forward, we just split each of the factors off into an equation by setting it to 0. So it's just x plus 4 equals 0, and then separately x plus 3 equals 0. So that part's quite easy. That'll never change. You always do that every single time. And then we just move the number to the other side to give us an x equals -4 solution and an x equals -3 solution for that one. That's the process. It never really changes. It's just a case of, can I get the factorizing correct? This last part here is literally never going to change. Splitting it off into the two equations and then solving it. So this bit here will be the same for all of these. Okay, so moving forward, similar format with this one. It's a plus and a plus, which is probably the easiest case. Some of these are a little different. When they've got the negatives, they tend to be more different. More difficult. So setting this to 0 in the two factors, x and an x, this one would need a 3 and a 3, because 3 times 3 makes 9, 3 plus 3 gives you 6. And then again, just splitting them off into the two equations. In this case, we've got a repeated factor, so we get basically the same twice. We probably, in that case, don't really need the second bracket. equal to 0, because we're going to get only one unique solution. We're going to get two solutions, but they're the same. So we say that we get one unique solution. So the solution would just be x equals -3. Okay, so that's that, guys. So that's just to make you aware that sometimes you'll get two solutions that are unique. Sometimes you'll get one unique solution. Sometimes quadratic equations don't have any solutions, but obviously if you're being given a question that you're being asked to factorize, then it should have solutions, or else it's going to be quite a rubbishy question. So, checking out this one, a little bit more difficult with that negative, but just going through the same process. So we're definitely going to need an x and an x to multiply to give the x squared term. So we need two numbers that multiply to give us a 15. More importantly though, a -15, and they combine to give a plus 2x. Well, 15 can only be 15 and 1 or 5 and 3. I'm going to go for the 5 and the 3 because a 15 and a 1, there's no way you can make a 2 with that. Theoretically, you can make a 2 though with a 5 and a 3 by making it +5 and -3, because +5 minus 3 gives you +2. So that's how we need to think about those. And also +15 multiplied to -3 gives you -15. So that's basically how we factorize that one. Just a little more difficult. But now we just do the same thing. We're going to split this guy off into two little equations. And then we're just going to go ahead then and solve them at that point. So we're going to get x equals -5 and then x equals +3. So that last part always pretty straightforward. Okay, so checking out this one, same thing again. It's also a trinomial, so we can go straight to writing down the two brackets. Go straight to putting in your x and your x. So 14, it could be a 14 and a 1, or it could be a 7 and a 2. I need to make a 5. 7 and 2 can be used to make 5, 14 and 1 cannot. That's how you need to think about those. So let's just go 7 and 2. Doesn't even matter where you put them for these ones. And then just thinking about the signs, right? We need to make a -14 when they multiply. That tells you that one has to be positive and one has to be negative. Because if they're both positive, positive, they would multiply to give a +14. And if they're both negative, they would multiply as a double negative to give a +14. So we need one of them to be negative and one to be positive. Because we need to make an overall -5, it would have to be -7 plus 2, because -7 plus 2 gives you -5. Cool, done. So we just, again, split these off into our two equations. So this one would give you x equals 7. X plus 2 equals 0 would give you a solution of x equals -2. So that's pretty much how we flow through those. Usually they're going to have two unique solutions, sometimes only one unique solution, even if you've got two factors. Trinomials are not easy to factorize, so definitely spend some time working on these. They come up in a whole bunch of areas of mathematics. They come up in pre-calculus and calculus courses, so you'll never get away from these, I'm afraid. We're going to do one more example. So let's try one where the coefficient of the x squared term is a higher number. Sometimes you'll see these, they're not maybe as popular, especially when you're starting out, as these ones. They are definitely at least one level of difficulty higher up. So let's just flow through this one and see what we get and how it differs. Well, it doesn't really differ massively in the overall approach. We're still going to factorize it as a trinomial. It is still a trinomial. The main difference is that to make a 2x squared, we'll need a 2x and an x. The process is still the same for making the n number. We need two numbers that times together, multiply together to make 5. Because 5 is a prime number, that can only be 5 and 1. But this one's more sensitive to where you put the 5 and the 1. Like up here, I went for +3 minus 5, but I could have gone for -3 plus 5. The order doesn't matter when you've got an x squared, well, a 1x squared. So for that one, and this one, it didn't matter. For this one, it does, because whatever number goes here, when you're considering multiplying out the brackets to get back to this point, this would multiply to the 2x, so the number is going to get doubled. So my question is it 5, 1 or is it 1, 5? Sometimes you just got to do these by trial and error. If you put the 5 there and the 1 there, then you're going to have a 5x and a 1 times 2, which is a 2x. So effectively you're going to have a 5 and a 2 trying to make an 11. That's not going to work, is it? Because you can't make an 11 with a 5 and a 2. If we put the 5 there though, the 5 times the 2 gives you a 10, and the 1 gives you another 1, so 10 and 1 does give you 11. So definitely more difficult. Go through a similar process, put in these first of all, and then think carefully about this. This one's not too bad, because at least with a prime number, you know the factors are 5 and 1. If that had been like a 12, for example, a 12 could be a 12 and a 1, it could be a 6 and a 2, or it could be a 4 and a 3. So you've got far more combinations to try out, remembering that this would need to be multiplied by 2. So if you chose 4 and 3, you would need to try 4, 3, 3, 4. 6 and 2, you need to try both combinations. So there's quite a lot to try out there. Basically, these require a bit of experience, so you just have to practice a few of these, I'm afraid, until you get to the point where you're comfortable with them. Okay, so just finishing this one off. Careful with this as well, because we need to make that 2x plus 1 equals 0. Second equation is x plus 5 equals 0. I'll solve the second one first, just getting the same sort of thing, x equals minus 5. This one though we need to solve as a linear equation, so taking an extra line of work in, moving the 1 to the other side, then dividing by 2, and we would end up with x equals minus 1 over 2. So when the coefficient, the number in front of the x squared, is above 1, these are definitely more difficult. So practice some of these guys, the normal trinomials, with the x squared term, and then once you're comfortable with those, practice some of these with the multiples of x squared. They're the tricky ones. They're the ones that no one likes. They are more difficult, but they're fairly common once you get far enough into working this type of quadratic equation. So it's easy to shy away from them, but they're likely to crop up at some point. So check out a few practice questions using that technique.